Thank you, thank you. Can you all hear me? Cool. You can't see my screen. That's impractical. Not that it's going to help a lot, because it's black. But okay, let's talk about, I have the loftiest title ever. Maintainable vibe coding, right? What the hell? What's this guy on about? So, to take you back a little bit, I'm one of the, what would you call it, the Commodore generations, right? So this is me. I think I was 7 years old. I got my first computer, a Commodore VIC-20. So a lot of shit has happened since that, right? So I can now relive this moment by just generating a video. Cool that I have sound on it, by the way. So that's one version. I could go another way and say, no, I want to see it from a different angle. I want to see something else. Of course, it's going to screw up all the letters and all that, but I can relive that moment. And it can go completely bananas, as AI does, right? So that's another version. And that's the beauty of non-deterministic AIs. And this leads to a lot of AI slop, right? So we are seeing this every day on social media, on the web, and everywhere. There's a lot of crap, basically, right? So what is the dream for a developer? So Mr. Andrei Karpov, I forgot his last name, said vibe coding. Was it all about like having good vibes only? Yay. That's what he kind of tweeted about. He's like, oh, yeah, we're now going to just vibe ourselves. We're just going to prompt stuff. And depending on the mood of the day, we're going to get computer stuff, well, software created. Awesome. So we can lean back, of course, and just do this with our pina coladas on the beach and just sit down with our pile of money and just say, yeah, make me something cool, right? That is what we're dreaming of, right? Am I right? Or is it more like actually trying to deliver more business value and less effort? And that's when I talk about kind of vibe coding today. It's more like, okay, let's bring it back to something more tangible, something that is actually makes sense in our everyday lives, right? Because chances are, if you're going to just vibe code yourself to software, it's not going to be that good. So let's shift gears for a moment and talk about something. Does anyone here, have you heard about the 5 waves of computing? Anyone? No? So 5 waves of computing, if you look back till the 1950s, we basically started off with this mainframe era. From the 50s to the 70s, we had the mainframes, like a centralized computer, didn't do much, was very incapable in many ways, had very simplistic UIs. We plugged a terminal into it, and we got like a simple terminal UIs. And that was basically it. So moving forward, we basically, from the 70s to the 90s, that was the area where, well, someone like me got their first personal computer. Right? So now, all of a sudden, they're more, well, first of all, we scaled them down. They're not as big as a room. They can actually fit on a desk. And it's more kind of accessible to everyone. We're kind of democratizing computing, right? And making it more accessible. And with it, of course, comes a lot of other things, like we can start playing games, we can entertain ourselves, not only is it for boring office work. So the next era, or the next wave, is more the internet and web wave, from the 90s to the 2000s. That's when we're seeing, well, the web comes alive, we can now connect computers together, we can actually do a lot more. And it gives us a hell of a lot more capabilities than we had in the previous wave. The 4th wave gives us the mobile and cloud. Right, so mobile is a paradigm shift in computing. It basically brings the computing power of probably what we had on the entire planet in the 50s to, well, early 70s, maybe even later, into one machine in your pocket, right? That's superpower. It's a supercomputer in your pocket. And of course, the cloud makes it a hell of a lot easier for us to actually deploy software, make it scale, and deliver software to a great number of users. So what we're now going into is a new wave. So from the 2020s, we're now seeing a different wave. So obviously AI is part of this, but for AI to actually thrive, we're going to start need to think a little bit different about what that wave of computing consists of. So it's going to be IoT. There's going to be devices out there. There's going to be sensors. There's going to be all this data that the AI needs to actually make AI do AI stuff. And that means also we need to put stuff on the edge. So be it on anything from cars to shipping vessels or whatever it is, or even in our homes, we're going to have computing powers in the edge, on the edge. So between all of these different waves, if you look at kind of the pressure on software, so going from no software, going from no computing to obviously mainframes, that was massive. But going from the different like mainframes to personal computer, the pressure that we as software developers are facing is pretty big. Because all of a sudden we have to deliver on expectations. We have to deliver on, well, first of all, when you got personal computers, there's a lot more users. And we have to start tailoring our software to a very different world. So the impact of that, we can say, is about 2 to 5 times, right? Going from personal computers to the internet and web, for us as software developers, the pressure on us is much higher, right? We now have to deliver a hell of a lot different user experience and, well, manage infrastructure in a different way than we used to. We have to scale things that we didn't need to do before at all. And going from internet and over to mobile cloud, maybe not so much, right? It's not that big of a leap. We're basically taking what we have in our data centers and moving it to the cloud. But we got that mobile thing that introduces new user experiences. So today, these are actually small little ripples compared to what we have ahead when it comes to AI. So if you look into the future, the estimate is that the impact of this is going to be, well, the rough number has been somewhere between 10 and 100x when you look at the pressure of software and the pressure of infrastructure and everything that goes with it, the data pressure and everything that we need to do to actually meet this wave. In this wave, there's going to be companies that's going to go bankrupt because they're not going to be able to actually keep up. We don't want to be in those companies, right? We want to be awesome. But there is a gap. There is a serious gap when it comes to software in this. And that is, if we look back to this, we are here, right? So we're in this wave, but our software architecture is here. We are building software the same way, pretty much, as we did back in the 70s. So that's a big gap. That's like, we need to do something about it. And when I say that, so SQL Server came out there, right? We're still doing SQL, or relational databases, right? That, well, things have moved on. So when we talk about AI, some people think about this guy, right? Scary. Is Skynet coming, finally? Well, if you judge from, like if you take a look at what's happening, if you ask these AIs, maybe it's already here. Maybe it's already trying to kill us in a very innovative way, right? Or like this, run around with scissors. That sounds like a good idea, right? So maybe it's trying to do something here, right? I don't know. Is poison good for you? Yeah, it is. It's actually very good for you. So, yeah. So maybe it's already here, but it's doing a lot of strange things. So if you look at kind of the vibe coding results as well, are we there yet? Probably not, right? When you see all these things plastered on the internet, so someone losing their entire database in production because that was the optimization the AI figured out. So what's the fastest system you can make? One without data, yeah, I'll fix your problem. No problem at all. So we see these things pop up all the time, and like that poor guy that just vibe coded his ass off, and nothing worked, right? And he bet all his money on it, poor chap, and no, it didn't work, right? So it's not for non-developers. This tool is not for non-developers. And if you go to GitHub and search for OpenAPI, I've done this, 11,500 hits. A lot of them were actually keys. And this is kind of the result of this vibe coding that's going on. And poor this guy who, well, he he knew what it kind of was doing, but yeah, none of it worked. None of it actually worked. So yeah, and we're kind of at the beginning of this, and we're already seeing things like this being, so if you go to NPM, you'll find this. If you go to the pips, you'll find these packages. Because of course you use AI to do uppercase. Yeah, it's the solution to everything, right? So that's happening now because we're at the beginning of this, and a lot of non-dev people are actually contributing to this community. So Stanford did a research paper recently where they actually started looking into kind of, okay, what is the tool good for, and what can we use it for, and what situations does it work in, and what situation doesn't not work in. And what is kind of interesting is that, well, when we get new tools, we tend to actually use that tool for everything, right? So that means things that are mundane, we start using it, like that vibe sort or uppercase thing, right? Mundane tasks is something that we start using it for. And I'm not going to go too deep on this. You can go to these links, and by the way, there will be links at the end. There will be a link to all the links. That's meta. All right. So, but I recommend watching this because it's quite interesting. And what they talk about is like, what they've seen the last couple of years is that rework is going up. That's a bad indicator, right? When we are creating new features and having to recreate them, right? And what has changed in the last couple of years? Well, AI tools. So it's quite obvious there's a correlation. Another thing is that productivity in general is going down. And this is back to what I was saying. We tend to use the same, well, when we get new tools, we use that tool for just about everything, even the mundane tasks. I've done this myself. I found myself a couple of weeks ago arguing with the bloody thing for a day. And I was like, step away from the keyboard. Step away, step away. And I took a break, came back and solved the shit in like a couple of minutes. I was like, yeah, that was, hope no one paid for that. And that's what we do. So that's why we see these numbers as well, because the mundane tasks, well, they're mundane. So why are we using this tool for that? And that's why we see productivity going down in general. It also says something about like when code bases increase and kind of productivity going down for larger code bases. The more code you have, the less productivity you actually gain from it. So I would highly recommend looking at this. So now we're here, right? So where do we go from here? Obviously, we go to the future to actually see how we can actually do things. So we can we can work with this tool, right? So let's figure out how we can actually work with this tool. So anyone in the room that's really good at context switching? Yeah, we're really awesome at that. Multitasking and context switching is actually perfect for humans, right? Anyone finding themselves in this situation where it's super frustrating, right? You're sitting there, you have a lot of stuff going on, and you're trying to actually juggle all these different things. And it's just daunting. Really, really hard to actually work with. The funny story is we try to anthropomorphize AI. So we try to make it human-like. And we think, when we talk about it, it's like, oh yeah, we see that it's responding in a human fashion. It must be a human. Oh, and we start acting like it is. But on the other side, we expect it to be superhuman, right? So when it comes to this context switching that we admit that we're bad at, we expect it to be really good. And that's actually where we're totally wrong. They are, so when anyone heard about the context window of AIs, right, LLMs? And how they fight for them to become bigger and bigger and bigger, that's the wrong path, right? Because the bigger it is and the more stuff you have in the context window, the more it's going to hallucinate. It's actually just as bad as us in context switching. So keep the context small and it will thrive in a much better way. But that means we need to think a little bit more about how we actually write our code and how we expect our code to be written. So over the years, we've been kind of doing this. We've been writing code for human readability, right? So talking about maintainable software, well, maintainability means someone on your team should be able to see the code, understand the code, and, well, add further to it, right? That's super important. But in this age, the fifth wave, we need to think more about how we optimize for the AI. How do we actually optimize for AI readability? If we're going to use this tool, and I'm not saying let's replace all of us with AI, because it's just a tool, and you would be a tool to replace yourself with the tool. No. So stay away from it. So use it as a tool, but we need to optimize so that we can actually leverage the tool for what it's good at. So start thinking about how we can actually create something that is AI readable. And we have to remember that it's just a big bag of words. It's a very big bag of words, but that's all it is. It has no feelings, it has no idea what you're talking about, it's just statistics, really. So we need to leverage that to the best of our capabilities, right? So one of the things that I kind of start with is take it back to first principles. Take it back to engineering principles, and I'm talking about software engineering principles. Let's start there. Let's kind of do a retrospective over the last few decades of good practices, good principles that works for us as humans, but could also work good for AI, for this new age. So, anyone heard about domain-driven design? And that's when this talk changed completely. I'm not going to talk, sorry, not going to go too deep on it. But what is domain-driven design? What is the fundamental thing in domain-driven design? Language. That is the most fundamental thing. Ubiquitous language. Represent your domain in language using words that not you as a developer only understand, but your domain experts, everyone working in this domain understands. That's the core thing. There's a lot of stuff in domain-driven design, but that will probably not be as good. A lot of the patterns and all of that stuff is, well, dated, to be frank, but also doesn't fit very well in the AI wave. But language, that's interesting. Another thing, so this, we have an uncle, so everyone in Norway have an uncle in America, right? Uncle Bob. He came with these principles, and he talked about like the solid principles. But I want to just highlight one of them. I don't care about the rest. But this one, so single responsibility, a single reason to change and all that. But let's face it, just if you have a method, well, it should just do that one thing that it promises to do. If you have a class that has a bunch of these methods, it should still represent this one thing. This is very good. These are very good principles when you think about what I said about the context window. Let's keep the context small. Single responsibility plays a role in this. Another thing that plays well with this is separation of concerns. If we said we want to focus, if we don't want to juggle a lot of things, so single responsibility helps us definitely on that, but also separation of concerns, separating out things that has, well, concerns could be validation. So let's say you have validation, you have logging, you have security, all these different types of concerns. If we start separating them out and not just have this big ball of mud with everything in it, it's much easier for the AI to actually deal with that. So separation of concerns, definitely something to keep an eye on. And back to, again, to focus. So if we start decoupling our software and aim for a low coupling model and keep the things that are related to each other close to each other. So decouple, high cohesion. Low coupling, high cohesion, right? So that means everything that is related to each other, keep it together. That means, again, back to the context window, everything that you're working on, let's say a feature, if that sits in one place, much easier to reason about. So another thing is composition over inheritance. Inheritance, well, it's kind of fundamentally flawed. I'm just going to leave it there. Object orientation sucks. No. So inheritance is a way to couple software, right? Basically, it's us developers, we do it not necessarily willingly in a way. It's not deliberate. We tend to optimize. We do abstractions and things like this, and we start figuring out, okay, so all these different things, that's just it's a vehicle. So we create something that represents these things in the abstract, rather than actually thinking, oh, it's a car, it's an airplane, it's a bike, it's a boat, and all this. And what abstractions give you, first of all, it gives you coupling. Let's say you're using inheritance to actually have a vehicle, and you have a car that inherits from vehicle. That's a coupling. And all of a sudden, these things are coupled together in a way. And you start figuring out what are the commonalities, and we put that into the base class and all that. But what you've done is basically create coupling. So think composition rather than actually do inheritance, because coupling is one of the things that actually makes, well, pollutes the context, right? So if you start polluting the context, you're basically making it harder again for the AI to work with this. So what if we sliced our code even further? So I talked a lot about these different things. All of these are strategies for basically reducing complexity in code. What if we do this on a structure level? What if we start thinking about how can I get to something that is very small, very focused, that I can let the AI work with? So vertical slices is something that is being talked about. I've started skipping the word vertical and just call it slices. And when we get to some samples, I think you'll see why. So we had DDD at the beginning. Of course, we have to add BDD at the end of this, right? So what is BDD? So given, when, then, behavior-driven development or design, whatever you want to call it. Specification by example is another name. This is all, again, about language. So when you start thinking about automating testing of your applications, this works very good because it's language, language, language. So given a user is not logged in, when I log in, it should be logged in, right? This is English. So that's the whole movement behind BDD. It's about expressing your tests, your automated tests using English, right? That's the basics of it. So this principle is also very good for doing that. And another thing that fits very well, if you look at event sourcing expresses state changes in a very different way. So a CRUD app will take an entity, bring that up to the front end, you'll change some properties on it, bring that same entity back, and save it. You don't know what went on. Event sourcing flips that on its head and says, no, let's represent those explicitly. So let's represent every state change very explicitly. So if you're thinking about opening a bank account, it wouldn't be a bank account and you just put some properties on it and save it. You would have this sequence of things that happen to it. Like you open the account, you might be depositing stuff to that account, you might be withdrawing stuff, and maybe you close the account eventually. This way of thinking is good on two levels. First of all, again, back to the language stuff, it's easy for the AI to reason about getting to these actual state changes. It links back to the domain-driven design, which talks about ubiquitous language, and is a good way to express changes in a system. The second part is we store these events. So core principle of event sourcing is that this is the source of truth. Your database is now a bunch of events, and you can now start training your AI on those events. So you're getting a double whammy, basically, from having this, right? So slices. Again, I've stopped calling them vertical slices, but just slices. I'm very fond of something called event modeling. And event modeling simplifies the thinking of software. Basically breaks it up to 4 different patterns, not 4.5, not 5. You can't expand on it. It's set in stone by the community, basically, gathering around this. So the 4 different slices talks about different things that happens to a system. So one slice talks about state change. And state change can come from like a UI, and you have a command, you have the intent to do something in your system. And from that intent, you might get an event that represents the actual state change. Another slice type is the view. So from these different events that we produce, we can want to actually look at data, right? So, well, we can then project from those events into what we call a read model, and we can show it to the user. Then you have automation slice, which is basically, so you have like a current state that, and you have something running in the background. Let's say you have something running on a timer or for something else that's actually triggering this. And basically want to do from current state, I want to actually do something, so a change. I want to do a command that eventually ends up being an event. So that's another slice. And then you have the 4th and last slice, which is basically a translation. So let's say between two different systems or 2 different parts of your system that shouldn't, well, they don't want to kind of own each other's data in a way. You can then use events as the thing that does the automation, right? Rather than a read model or current state. So with those 4 slices, you have enough to build most information systems. And it all starts with structure. So I hope I've tried to make this as big as possible. Is it readable in the back? Yes? It starts with structure. So let's say I have this system. It's a library system, and there's a folder called features. And on it, you'll see that I have now 3 features. So authors, inventory, lending. We go to the next. Within authors, and this might be hard to read, and I can't do anything, sorry. I can try to, no, that doesn't work. Okay, I'll walk you through it. In this, we have a couple of slices. We have a registration slice, so that's a state change slice. And then we have a listing slice, which is basically the state view slice. So again, we're just on structure right now. And for the authors feature, you can see composition. And there might be someone feeling their vein going on, because we see React and C# files side by side. That's crazy. And it becomes worse. So next, if we open the registration, what you see here is, well, there is a registration file there, and you'll see some TypeScript files, and you'll see some React files, and you'll see at the top there the tests for that thing. And it says, when registering, and there already exists one with the same name, right? And it's going to have assertions in there. And there are no authors, again. But what you can see here now is that that's a feature. That's the front end, the back end, the everything, right? In one go. There's no layers. Complexity has been removed. It's just simplified, simplified, simplified. But it's still following the principles. So if you start looking into the code, you'll see that a command looks like this. A command is basically just a record with whatever you need to be able to do that command. And it has this handle method on it that can go and, well, return the state change that you want it to actually do. And the state change is represented as an event type. So we say register author, author registered is the event. And of course, it can do some, if it needs to do some validation here, it can do that. But we tend to actually put validation in a different place. And that's what you see at the bottom there. There's a constraint that says, well, it has to be unique. You can't register the same author twice, right? So that's a unique constraint. And other validators would also follow that same thing. And what happens in this particular scenario, we do generate some TypeScript code actually from the C# code that can be used directly in the front end. So the front end for this is that. And you can see it has a register author.use, and it just basically consumes that command. And that's all the code you actually need for that feature to work. And if you look at the test part, the BDD, so you have a namespace there saying when registering, and the class is called, and there already exists one with the same name, and we set up a context for it, should not be successful, should have appended only one event. It does append one or two events, right? So that's one test, and the other test that says there are no authors, should be successful, should have appended only one event, should have appended one author register event, and as you can see, it's English, right? Okay, implementation details, yeah, sure, but it's given when then and very clear. And again, very focused, because what we tend to do is have these big test classes with a lot of different scenarios. What we've done here is actually extract the scenarios, first of all, into a structure, a folder structure. So we have a top-level thing, a structure that says when registering, and then we have a different kind of sub-scenarios or context, if you will, for that. So if you go into the next one, state view, you'll see it starts off with a read model. And you basically then have a read model, which is very simple in this case. And by the way, when you switch your mindset around for this, there's not just one way of representing data. We don't have to represent data as it sits in the database. We can represent it in however we want to for the slice, for the feature that we're working on. So this only needs to display a list of authors. So it only has that. It has the ID of the author and the name of the author, and it has a query on top of it that actually returns that. And we have then a projection down there that takes all those events, or that one event in this case, and just creates that read model. And as you can see on the right side, that listing code is accurate. That's exactly what you need. You need a data table, and you can then bind it to that query, and you're good to go. And of course, same goes on for these different slices like automation. Like we have a read model, and we have a command that will do stuff, and we handle it. And this one in particular will actually return a validation result saying, well, we don't have that available. If it doesn't have it available, otherwise it will return an event that says, okay, book reserved. And last but not least, something that's based off of existing events. And then we have something called a reactor up there that will produce, will actually call the command pipeline and actually execute a command when an event happens in this particular slice. And again, same thing, it will produce an event that we will save. So with all of that, I figured that should be enough. So this was my hypothesis. And this is the cool thing. So when you submit talks to places like this, at least I do, I start with an hypothesis. I don't necessarily know if I'm going to make it, right? And then they give, well, email comes in your email and say, yeah, you can come and talk about this. Ah, fuck, shit, I need to prepare. So my hypothesis was that I was going to be able to actually do this, right? So, and at the same time, I'm actually working with clients, and I wanted to actually prove it with them as well. So I do this in production. So what I wanted to do is, in this case, I wanted to prove that I can prompt it. This is just a bunch of features I wanted to make. Build me a library system. And I realized this morning I should have said before, I should have said, dude, comma, build me a library system. Because that would be vibey. But basically what I said, okay, I do have the different features. So authors, should be possible to register authors, capture first name, last, blah, blah, blah. Should be possible to view these things. Should be possible to delete an author, all these kind of things. And I do that for the different things. And some of them are linked together and some of them are not, right? So a small eternity later, which is actually not that bad. An eternity is 10 to 15 minutes. Later, it comes back, has, for Claude Sonnet 4, created a UI that looks like this. Pretty much what I was kind of hoping it would do. So basically you have a home screen, you have all the different features, you can navigate, you can go and register authors, you can go and register books. But what I was aiming for was, of course, the code. It created the exact structure that I was hoping for, right? With all the high cohesive kind of structure, everything in the slices. And you can see, okay, it's going to be hard to see the actual code here, but it did actually create the perfect code. Exactly how I wanted it. Except for one thing, which annoyed the shit out of me. You see anything missing? Tests. I gave it clear instructions, write the bloody tests. But it didn't. But it created the UI as expected. And yeah, it was kind of nice. But again, back to the tests. So I told it, what the hell, man? What's going on? Why didn't you do as I told you? And of course, I had to shame on you. So you're absolutely right, and I apologize. They are so polite. So I tried with others, like we now have GPT-5 Codex that just came out. And it created tests. I was happy again, right? But it's the same structure. And it was actually doing more than it was kind of implied that it should do things, and it did. So it did more than I expected. Created this full structure, and pretty consistent to what Claude did. Then I went, okay, 4.5, Claude Sonnet 4.5. And again, pretty much the same thing. Same structure. Now it actually gave me some tests, but it's very consistent, which is very, very good. So how is this possible? Because anyone who's worked with this know that it's very inconsistent. It's not very deterministic, right? So whenever you prompt something twice, chances of getting the same result is slim to none. And mind you, I'm doing this across different models, and I'm getting pretty consistent answers back. Well, surprise, surprise, it's a lot of instructions that goes into actually making this possible. So put it on Rails. Really, just put it really on Rails. And you can't, well, you can be too specific because it can get confused. But be very specific about what you actually are trying to do. So I use like the bottom one, so I use Copilot. I use VS Code and Copilot, and out of the box you can go put a Copilot instructions file at the root of the GitHub folder, and I use that as the general instructions. That's more like top level, language agnostic and not very specific. It's more like just general rules. And then I do more specific ones to actually guide it to do the right thing. So for the general one, it's very like one-liners, very simple, like, okay, honor the blah, 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 just stay within the boundaries of sanity. Well, what I do is, one of the things that you can do with GitHub Copilot instructions, you can go in and apply it to different files. I like this over the agents MD file, because the agents MD file is basically based, well, you put it anywhere in the structure, and it will start using those instructions. But I can now keep all my instructions in one place, and I just tell which files it applies to, which folders and all that. You give it basically a glob pattern. So one of the things that we do is that we don't use primitives in our code. We want to express everything with language, something that makes sense. So instead of using string, int, GUID, whatever, we create what we call a concept. It's basically a domain concept. Something that is readable, something that is understandable. And so these are instructions for that. And you can give it examples, right? And these are just markdown files, so you just give them examples and say, okay, this is how, this is an example of how that looks like. And you can give it multiple examples if it kind of varies, right? So I do that for instance, how to write specs. We don't call them tests, and that's the first thing I tell it. We call automated tests for specs, right? That's the name of it. So whenever I want to get some specs, I just go and do that. I tell it to write some specs for me for this file, for the current file I have open. And I give it the structure. This is how it works. This is how you specify. This is naming. This is just, by the way, all of these files are much larger than the screen could fit. So it's very, very specific on how to actually do these different things. And you see that for like the vertical slices thing, where I actually go in and I had to be very strict with it, mandatory, and like bold, hello, stay with this, do this, otherwise it kind of derails. So, but again, this file alone is, I think, 600 lines of instructions, just to keep it on Rails, right? But the result is pretty good. So I basically created a compiler for English to programming language, X, in this case, C#. And of course, to create instructions, if you're using something like, actually both, I think Visual Studio and Visual Studio Code has this built in, where you can actually go and tell it to, well, analyze my project and go and create instructions. They're not going to necessarily be perfect, but it's a very good start to start understanding how to write these instruction files. There's also a place where there's a lot of different instructions that you can actually get inspiration from. So I would recommend going there. If you're using Copilot, there's other awesome lists for different editors. So another thing I would highly recommend is going into MCP, so Model Context Protocol. So what we did is we extended, we created a vertical slices MCP server. And what that does, it understands the structure, it understands the code, and it understands the entire project. And you can basically ask it, how does this project look like? And it's not going to do an analysis of the project at all. It's actually going to go and ask that MCP server, which returns a JSON structure that says, I have these features with these vertical slices that produces these events, and you can use these commands, read models, queries, all that stuff, and all the rules and all that. And what's cool about it, so this is actually from a production system. So we asked it, just, go and ask, what are the features and slices we have here? And it basically comes back and, yeah, this looks like an emergency medical service application with the following features. And yeah, you have these different slices. So mission triage is a type of state view, purpose, manage and view mission priorities. It has this query on all these different read models with blah, blah, blah. And it just goes and does that. And the reason we did this is because the happy path is, of course, file new project, and you set it to do this, right? This initial instructions that I give it. But what if you want to go and add features or change an existing feature? Instead of it having to go in and do a full analysis of the existing code, you can actually go and just, with an MCP server like this, it will be a much smaller footprint in your context window. And it will get there faster, and it will not screw up as much. And go meta. Go totally meta on this. So what I do is, when the AI screw ups, I ask it to fix the instructions so it doesn't screw up the next time. That is a killer feature. That has saved me a lot of time. Instead of me trying to figure out why is it screwing up, right? So I do that all the time. I also ask it to optimize it sometimes because they can get big, right? So can you look at it and find duplication, because it's easy to get duplication. All these kind of things, just use it for what it's good at. It's good at language, right? And good at understanding, well, basically itself. So use it for that as well. Another part of this is, and this is the shameless plug, I do work on something called Kratos, which is a open source thing that does all of this thing, right? So it has all the code that I showed is basically all the constructs for commands and events and all that stuff. That's coming from there, and that's of course helpful if you're building in this way. But use it as inspiration, whatever you want to do, and just have a look at it and see if there's anything useful for you. So I said we need to start coding for AI. But I would actually argue we should be coding for readability in general. It doesn't really matter if it's for an AI, because the type of stuff that I showed you today will be understandable for a human as well. Remember, the large language models are based on language that we as humans have created. So why wouldn't it? So all the principles should be applied no matter what, right? So let's work together with the AI and actually, well, help it and help ourselves at the same time. And I see that I have a lot of time, so I can dance, but but build responsibly. That's basically the message. And this is the link, the meta link to the links, if you want to. So I'll give you a few seconds. And I was so happy I could steal Bitly HelloStavanger. They didn't think about that. Okay. With that, let's go to the future. So. But since we do have time, we can do questions if we want to. I think we have about 10 minutes. Any questions? Yeah.
Yeah, so I'm going to ask maybe it's a stupid question, but when I look at your code structure, this is a bit dated because I'm not used to structuring it that way. Would your approach, especially with these structures that you have in the beginning of your workspace and these at the code, would that have worked with a more traditional architecture, or is that like critical in this?
Okay, so I'm going to repeat the question. Question is, would the instructions work with a more traditional structure, more an architecture, rather than just this way? It will work. So instructions are just rails, right? The benefit of the structure is that it gets less confused, really. So it's more about just helping the LLM structure things and keep a clean context. Like for instance, one of the things that I forgot to mention is that I have, during a workday, I have maybe hundreds of new contexts. I just create context all the time. I keep it as small as possible. So just keep that in mind, that whatever gets into the context is what kind of screws it up. So good structure, good separation on your code is basically the message here. It doesn't have to be like this. Might be to the extreme in one way if you're unfamiliar with it, but it's definitely helping, right? So it's just about the core principles of just making, like what I said, single responsibility, separation of concern, and just thinking about these things consciously and keeping things small. That's basically it. Yeah. Anyone else? No? Okay. If there's no more questions, I thank you all for coming to my talk. Yeah.